Welcome dear learners, we are continuing Unit 1. The Unit 1 title is Chemistry as a Science Discipline and Scientific Analysis. In the present module, we are discussing methods of representing precision in analytical data. In this module, we come across precision in analytical measurements, accuracy versus precision, an overview of various statistical methods to represent precision, and problems based on the statistical methods under our discussion. First of all, we are considering precision in analytical measurements. In analytical chemistry, which is the chemistry of analysis, we have to take large number of measurements. These measurements can be in the form of classical experiments, or we can use various kind of instruments to take measurement. In all these type, there are several measurements are involved, and in taking such measurements, there do occur the concept of accuracy as well as precision. You are all familiar with the term accuracy. Accuracy simply implies the difference between true value and experimental value. This difference as such is termed as error, and if error is minimum, the accuracy is maximum. That is, accuracy is the closeness of the true value with the experimental value. Higher will be the closeness, lower will be the error. That is, higher will be the accuracy, lower will be the error. But the concept of precision is somewhat different. You imagine the condition where you are taking continuous set of readings with the help of an instrument. During these measurements, if we got some values which are very close to each other, that situation is termed as precision. Or you can say that there is precision in measurement. Thus, in analytical chemistry, precision refers to the degree to which repeated measurements under unchanged conditions yield same results. It measures the reproducibility or consistency of results, but does not necessarily indicate how close the results are to the true or accepted value. This implies that precision doesn't imply accuracy. It is the most important point relating to precision and accuracy. It should be noted that if you are getting a set of values, these values are very close to each other. With that justification, you cannot argue that the obtained values are accurate. Obtained values may or may not be accurate. Thus, precise values may or may not be accurate. Let us go through some simple examples which illustrate the concept of precision. Measuring the concentration of a solution using the same spectrophotometer 5 times yield some results. These are the results. The values obtained are 0.123 molar, 0.122 molar, 0.124 molar, 0.123 molar, and finally 0.122 molar. Whenever you are carefully analyzing these values, it is very well clear that the values 0.123, 0.122, 0.124 and 0.123, also 0.122 are very close to each other. There is a difference in the range of 0.001. That means the concentration measurement using spectrophotometer obtained these results which are highly precise. That is, the precision is high as far as this experiment is concerned. Now, we can take another example. If there is a balance which consistently measures the mass of an object as 5 gram, 5.01 gram and again 5 gram in the third trial. That is, we took the mass, the weight 3 times. We got 3 values like this. It is very well clear that these 3 values are very close to each other and hence the result is precise because there is minimal variation between the observed values. Now, another example for precision is here. An analyst titrate a solution of hydrochloric acid, that is HCl, against sodium hydroxide. Here the titration is between an acid and a base, so it is an acidimetry titration or alkalimetry titration, which is the part of the volumetric analysis. You know the basic concepts. And the analyst conducted titration 3 times and obtained endpoint oleums or endpoint values as 25 ml, 26.5 ml and 23.8 ml. On careful analysis of these 3 values, we can arrive at the conclusion that there is large difference between 3 set of values. So, this measurement or this analysis is not precise. The values obtained are not precise. This indicates that these values depicts low precision. Now, another example depicting precision is a chemist use a titration method to determine the concentration and the chemist got these 3 values. The first value is 0.475 molar, second one 0.476 molar and the final value is 0.474 molar. What is your justification about the precision of this experiment? It is clear that the measured values are very close to each other. That indicate high precision in this analysis. That all about certain examples associated with the precision to illustrate the concept of precision. Hope you are very well understood the concept associated with the precision. Now, precise values may or may not be accurate. Precision indicates reproducibility or reliability of the measurements. For a better understanding, we have to remember the concept of accuracy also, and we have to make a simple comparison between accuracy and precision before moving on to statistical methods for expressing the precision. Now, we are considering accuracy. You know about accuracy. Even though that is the situation, we can just revise the concept of accuracy. In analytical chemistry, accuracy refers to how close the measured value to the true or accepted value of the quantity being measured. Accuracy evaluates the correctness of a result, combining the effects of systematic errors or bias and random errors. So, accuracy is the outcome of minimal systematic error and random error. Now, we can illustrate the concept of accuracy with some simple examples. A solution of HCl is titrated against NaOH as usual in a volumetric, acidimetric or alkalimetric analysis, and the calculated concentration of HCl is 0.100 molar. This is the result got when an analyst perform this titration. Let the true concentration as confirmed by the standard is also 0.100 molar. So, it is clear that the true value is 0.100 molar and the experimental or observed value is also 0.100 molar. What is your conclusion? We can conclude that the result is highly accurate. Experimental value and the true value are the same. So, the result is 100% accurate. Now, another example for accuracy. A chemist uses a titration method to determine the concentration and get values 0.498 molar, 0.503 molar and 0.501 molar. And in order to get a comparison, we have to compare it with the true value. Let the true value or actual value or the actual concentration is 0.5 molar. Now compare this actual value with the observed value. The observed values are very close to each other, very close to the true value. Thus, the measured values are very close to the true value of 0.500 molar, and that indicates this method adopted is an accurate method, or the results are accurate. Another example for accuracy. You consider a situation in a laboratory where you obtain some weight measurements. You go to the weight measurement of 52.2 gram for a given sample of NaCl. This is the observed weight. You are provided with a sample of NaCl. You took the weight in a balance, in an analytical balance, and you got the weight as 52.2 gram. But the actual weight is given here is 80 gram. Then you can say that your measurement is not accurate. Why your measurement is not accurate? See the difference between 80 and 52.2. That difference is huge. The deviation of observed value from true value is very high. In this case, your measurement is not close to the known value, such that your measurement is inaccurate or simply not accurate. Now we are discussing a comparison. This I am specifying here for the sake of a revision, and we are now just considering the comparison between accuracy and precision, and our title is Accuracy Against Precision or Accuracy versus Precision. Accuracy and precision are very similar in the fact that both of them refer to some measurement quality. Both indicates the measurement quality. In the case of accuracy, the measured quantity is very close to actual value. In the case of precision, if you are taking repeated measurements, the values obtained in repeated measurements are very close to each other. So, accuracy and precision both depicts measurement qualities, but they are very different indicators of measurement. Accuracy doesn't mean precision, precision doesn't mean accuracy, so and so. Precision does not imply accuracy is the most important thing that we have to point it again and again. Now, experimental measures may show high accuracy, high precision. In this circumstance, this is the first condition whenever we are making some comparative aspects of accuracy and precision. So, accuracy may be high or low, precision may be high or low. In such a case, whenever you are combining accuracy with the precision, 4 different possibilities may occur, out of which this is about the first possibility, where both are high, that is accuracy and precision are high. Another possibility is both are low. Another possibility is accuracy high, precision low. Another last possibility is just opposite to the last statement. So, we can just move through the various possibilities whenever you are combining accuracy and precision in the case of a quantitative chemical analysis. So, the first possibility is high accuracy and high precision. Results are close to both the true value and are also close to each other. Also close to each other means the values are precise. High accuracy means the obtained values are close to the true value. So, this is the first possibility. Moving on to the second chance, that is high accuracy and low precision. Here accuracy is high, which indicate the fact that the results obtained are close to true value, but the obtained results are not close to each other or they are not consistent. This indicates the situation of high accuracy and low precision. Moving on to next possibility, that is low accuracy and high precision. Results are consistent. The obtained results took set of measurements. The values obtained are very close to each other, but they deviate largely from the true value. In such a situation, you can say that there is low accuracy and high precision. And finally, there is one more chance, that is low accuracy and low precision. In certain cases, you took a set of measurements, the measurement values are not close to each other individually, so poor precision or low precision, and these obtained values are again highly deviated from the actual value. Then that situation you can refer it as situation of low accuracy and low precision. It should be noted that as far as the analyst point of view is concerned, this is the very poor performance from that measurement. So this kind of measurement is not at all accepted in analytical chemistry and in measurement and in science also. Now this is a comparison where we are just mentioning 4 situations what I mentioned earlier. The first case, accurate and precise, means high accuracy, high precision. This is a shooting range. This is the picture that we are generally placing in the case of a shooting range. And in this, the center point is the target. One person using the gun shooted exactly at this position. So this is accurate as well as precise. And he made several trials also. Consider the second one. In the second situation, the actual target is at the center, but you got a result which is away from the point, and these are some points. So you can say that the result is precise but not accurate. And next situation represents accurate but not precise, and the final situation represents non-accurate and not precise. So there are 4 possibilities as far as accuracy and precision considered together in the case of an analytical measurement. Now we are at the core portion of this discussion, statistical methods to represent precision. We are highly familiar with the concept of precision, concept of accuracy, and the relation between accuracy and precision. Now we are entering into another area that is nothing but statistical methods to represent precision. Precision refers to the degree of agreement in repeated measurements. Statistical methods to represent precision help to quantify and communicate how consistent a set of measurement is. Now we are discussing or we are considering various statistical methods used to represent precision, or we are now having an overview of various statistical methods which are used to represent precision. There are several methods to represent precision, and these methods include number 1, mean; second one, average deviation; third one, standard deviation abbreviated as SD; fourth one, relative standard deviation or RSD; fifth one, coefficient of variation or CV; sixth case is variance. So we are having these 6 important statistical methods to represent precision. So now we are having these 6 statistical methods, and we can move on to light details of each of these methods. In the coming modules, we can consider each of these statistical methods individually, and we can do several problems and detailed analysis of each of the statistical methods. Now, in this module, we are having an overview of these statistical methods. First of all, we are discussing the statistical method mean. You know, mean is the arithmetic average of a set of values. Mean is calculated as, mean is abbreviated as x bar, where x is a measurement. It is the sum of xi, that is you are taking n measurements, x1, x2, etc. up to xn, the whole divided by n. Suppose you are taking 5 measurements, then x1 plus, x2 plus, x3 plus, x4 plus, x5, the whole divided by 5 will get the average or mean of the data, where xi are individual values and n is the number of observations. So, by using this expression, it is possible to calculate the mean, which is the most simple method to express the precision also, and it serves as the central value around which precision is evaluated. It provides a reference point for calculating other measures of precision. You know, there are several methods like standard deviation, average deviation, etc. All are related to this basic quantity, that is mean. So, mean provides a reference point for calculating other measures of precision, Now, the second statistical method to represent precision, it is nothing but average deviation. What is meant by average deviation? The mean of the absolute deviations of data points from the mean. This is called average deviation. Remember this definition. The mean of 2 means are included in this definition. So, you have to handle it carefully. The mean of the absolute deviations of data points from the mean, that is mean of absolute deviation from a central point, that is the average or the mean. Average deviation can be calculated by using this expression, sum of modulus of xi minus s bar divided by n. It is clear that x bar is the average and xi represents individual measurement, and also xi minus s bar modulus represents the absolute deviation of each value from the mean. Absolute deviation of each value from the mean. So, if you are getting a set of values, first you find out the mean, that is x bar, then find out the difference of each values from the mean, takes its sum and modulus, followed by division with the total number of measurement n. The quantity obtained is called average deviation. That is why we are saying average deviation is the mean of the absolute deviations of data points or data from the mean. So, we have two means. Since you are dividing this deviation by n, it is a mean. Moreover, in this there is an x bar, that is also the original mean. So, this average deviation is most significant. Now, this average deviation is a simple way to measure the average amount by which measurements differ from the mean. Average amount by which the measurements differ from the mean. So, there is a central point, there is a mean. You have to first consider the deviation of each measurement from the central point mean, then take its average, that is the average deviation. But one important thing you have to note it, this average deviation is less commonly used when compared with the standard deviation. So, the more appropriate quantity is there, it will come, that is nothing but the standard deviation. So, average deviation is less commonly used when compared to standard deviation. Now, we are entering into another statistical method, the most important statistical method to express the precision in analytical measurement, that is nothing but the standard deviation. Standard deviation is abbreviated as SD, the square root of the average of squared deviations from the mean. So, standard deviation as such a square root. Square root of what? Square root of average of squared deviations from the mean. Average of squared deviations from the mean. Standard deviation SD can be calculated by using the equation under root sigma xi minus s bar the whole square divided by n minus 1. Remember, this denominator may have some confusion. In certain cases we are using n, and in some other case we are using n minus 1. But in analytical chemistry, since we are dealing with the samples of small size, we have to use n minus 1. More details of population standard deviation and several kind of standard deviation that we can discuss in coming modules, and we can do several problems accordingly in later modules. But we are just introducing the concept of standard deviation now itself. SD is equal to under root sigma xi minus s bar the whole square divided by n minus 1. Remember, we are now using n minus 1, where n is the total number of measurements. Even though n is the total number of measurements, we are using n minus 1 here. This is because in this equation, denominator is n minus 1 rather than n, because the total number of measurements, the value of n is small. That's why we are dividing it with n minus 1. Now, the standard deviation quantifies the spread of data around mean and is widely used in precision analysis. It is one of the most important technique in precision analysis. A smaller standard deviation, this point is very significant, a smaller standard deviation indicates higher precision. So, if you are having a set of values, you can say that it is highly precise if the magnitude of standard deviation is less. Now, relative standard deviation, it is abbreviated as RSD. You are familiar with the concept of standard deviation. And now we are focusing on another concept, another statistical method used to express the precision, that is relative standard deviation. The relative standard deviation is another measure of precision, absolutely. RSD is given by the expression standard deviation divided by mean. You are familiar with the standard deviation, you are familiar with the mean. So, in order to get a relative standard deviation, you have to divide standard deviation with the mean of the measurements. This is a relative standard deviation. This is also a significant quantity, and in many cases, the relative standard deviation is expressed as a percentage. Then it is another statistical method that we will discuss now itself. RSD, you have to understand here, RSD is equal to standard deviation divided by x bar. S bar is the mean, SD is the standard deviation, RSD is nothing but relative standard deviation. The next method, I simply told you the point that relative standard deviation is sometimes expressed as percentage. That percentage is known as another statistical method, that is coefficient of variation, abbreviated as CV. Relative standard deviation can be represented as a percentage and is known as coefficient of variation. Therefore, what will be the numerical expression for coefficient of variation? It is here. I told you the relative standard deviation multiplied with 100, it is converted to a percentage, or RSD can be expressed as a percentage. RSD percentage is called coefficient of variation. So, CV is equal to SD divided by X, this is RSD or relative standard deviation. This part represents relative standard deviation, that to multiply with 100, or CV is equal to RSD multiplied with 100, or RSD into 100 equal to CV or coefficient of variation. This equation is very important. You have to remember it, you have to keep it very well. This coefficient of variation or CV is used to assess precision in terms of percentage. Here the final value is a percentage. So, it is used to assess precision. CV is used to assess precision in terms of percentage. Now, another statistical method used to express precision is the variance. What is meant by variance? Here is the definition. The square of the standard deviation is called variance. So, standard deviation standard deviation has some pivotal role. Standard deviation is related to so many other things. For instance, standard deviation square is called this variance. Standard deviation divided by mean is called relative standard deviation. Relative standard deviation multiplied with 100 is called coefficient of variation. So, in these kind of statistical data, standard deviation has a pivotal role. This variance, that is the square of standard deviation, is given by the expression sigma xi minus x bar square divided by n minus 1. If there is a square root, you can call it as standard deviation. I just removed the square because on taking the square of standard deviation, that square root term disappears and you are getting variance equal to sum of xi minus s bar square divided by n minus 1. Again keep the fact that in the denominator we are using n minus 1 instead of n because we are dealing with the small samples. And this variance is primarily used in theoretical contexts such as regression, correlation, analysis, etc. These terms, regression, correlation, analysis, etc., we can deal in somewhat more detail in coming modules later. Now, we can have some problems associated with the statistical technique we have passed through. So, we are now having several statistical methods and their expressions with you. So, we have to use that expressions to find the answer to the following problems. Let us enter into some MCQ based problems which deals with the concept that we learned associated with the statistical representation of precision. The first question in front of you is this one: what is the unit of variance? The options are here, the same as the data, the square of the unit of the data, dimensionless, that is there is no unit, reciprocal of the unit of the data. You know what is variance? Variance is square of standard deviation. Square of standard deviation. This is your answer, square of the unit of the data. Because you are having standard deviation, take its square implies you are taking square of the original data. So, its unit is square of the unit of the data. Option B is the right answer. Now, we are going to next problem. Which of the following is a measure of the spread or dispersion of data? You know, standard deviation represents the spread or dispersion of data around a central mean. Among these options, mean, standard deviation, median and mode, the right answer is standard deviation. Now, we are entering into next problem. Which of the following represents coefficient of variation? There are certain expressions. Expression A, option A stands for sigma xi minus s bar square divided by n. Standard deviation divided by mean multiplied with 100. Maximum xi minus minimum xi divided by n. Median divided by mean into 100. Coefficient of variation. Coefficient of variation is nothing but relative standard deviation percentage. So, standard deviation divided by mean indicates relative standard deviation. It should be multiplied with 100. So, look on to option B. Standard deviation divided by mean is RSD. RSD multiplied with 100. RSD percentage is coefficient of variation. So, your answer is option B. Standard deviation divided by mean multiplied with 100. Moving on to another problem. The standard deviation of a data set is 5 and the mean is 50. What is the coefficient of variation? Standard deviation divided by the mean. you are getting relative standard deviation. Relative standard deviation should be multiplied with 100 to get coefficient of variation. That is, coefficient of variation is RSD into 100. RSD is standard deviation divided by mean. So, 5 divided by 50 multiplied with 100. 5 by 50 multiplied with 100, that is 500 divided by 50. So, you are getting answer as 10, that is option C. Now, another problem. For a data set with values 4.2, 4.5, 4.7, 4.3 and 4.4, calculate the coefficient of variation CV if the standard deviation is 0.2. In order to proceed, in order to get to the answer, you have to proceed in some systematic steps. You have to pick the answer from these options. Options are here itself, but you have to proceed in a systematic way. First of all, you have to calculate the mean of these set of samples. The mean of this set of samples is x equal to 4.42. You have to add the values together and divided with the total number of measurements, that is equal to 5. So, you got the value as 4.42, x is 4.42. So, calculate the coefficient of variation. What is coefficient of variation? Coefficient of variation is relative standard deviation multiplied with 100. The standard deviation is here, it is 0.2. 0.2 divided by mean, that is 4.42, will give you the relative standard deviation. So, you have to do like this, 0.2, that is standard deviation, divided by this mean 4.42 and then multiply with the 100. You will get answer CV equal to coefficient of variation equal to 4.5%. You can see standard deviation, which is 0.2 divided by mean of the sample, that is 4.42. So, 0.2 divided by 4.42 multiplied with the 100, you are getting RSD percentage. RSD percentage is called the coefficient of variation. Hence, the right answer to this problem is option C, that is 4.5%. This is about the last problem of this discussion. If a chemist records the concentrations 4.8, 5.2, 4.6 and 5.4, what is the standard deviation? These are the options in front of you. You have to find out the standard deviation. For that, we have to first calculate average of this measurement. Average of this measurement is obtained by adding all these values and divided with the total number. You are getting the average as 5. S bar is equal to 5. Now, you have to find out the deviations of each values from the mean and take its square, and you are getting the square of the deviation, that is equal to 0.4, and finally that 0.4 divided by 4 minus 1 will get the square of standard deviation, that is nothing but the variance. If you are taking square root of the variance, you will get to the standard deviation, and the standard deviation is equal to 0.35. That means your answer is option B, 0.35. Thus, in this module, we learned about the various kind of statistical methods to express the precision, and we have familiarized the concept of precision as well as accuracy. That's all about this module. Have a nice learning experience. Thank you.